transformer technology, power systems technology, and a whole bunch of other things we do. My guest today is Johan Fornell. He is the CEO of GMT International and Acalec, and we're going to talk about both companies. Johan, thank you for joining us.
My pleasure, Alan.
Okay, I'm going to learn something. I learned something new in getting ready for this interview. I never knew what a bunt was before. And so I thought, okay, this company in France makes these things called bunts. That's GMT. You've been the CEO of GMT International for correct? 3.5, 4 years?
Well, I've been working for GMT International for the past 12 years. CEO, yeah, maybe 3.5 years.
Okay.
Yeah, correct, yeah.
All right. And if I gave you a little bit more seniority, I hope that helps anyway. But
Okay.
before we get to that, tell me a little bit about your background and what got you into the transform. Well, actually, the GMT International, because you make more than just transformer bunts. But tell me how you got involved in it. What's your educational and work background?
Well, I've got a chemical engineering degree, and quite long ago now, I did start my career working for oil company,
Yeah.
British Petroleum first. And then I switched to service company, still in the oil business. I worked for ABB, but not the electrical divisions, the petroleum division.
Yeah.
Then, I had a good opportunity to move to automotive. At the beginning, I was optimizing fuel production at BP and the ABB. And then I switched to automotive industry to use the fuel.
Yeah.
Somehow I ended up in the electrical business. It's still in the energy, but not much to do with the fossil fuel and things like this.
Well, no, you used to create the product that now you're trying to create the solution from that product doing damage. So
you can say so, yeah.
It's a nice circle that you've gone into.
It is a nice circle, yeah. You start to pollute and
Yep. You're a chemical engineer. I'm a mechanical engineer, and we're both in the electrical industry. And I don't know why that is, but it's partly because the industry is changing so rapidly. That's something that I want to talk about. Let's talk first about GMT International. GMT International is primarily France, and Acalec is primarily the rest of Europe and the rest of the world. We don't have anything yet happening in the United States. We need to encourage you to come to North America, Canada, the United States, but we'll talk about that at the end here. Talk to me a little bit about why the two companies, why GMT International and then why Acalec?
Well, it's just because of the history. At the beginning, we had only GMT and the main business was in France. This started back in 95.
Okay.
And a few years later, the previous CEO decided to send someone to Spain to study the potential business in Spain. And well, this was fairly, let's say, potential interesting business in Spain. So they decided to launch a new company, to start a new company based in Spain for the Spanish business initially. And this company was called Acalec. This was back in 2005. Okay. And then we started to develop the export business outside of France and outside of Spain, working first with Great Britain, Belgium, Italy, Switzerland, and then overseas business, not yet to the US, but we have been exporting material to Latin America, to Asia, Australia, and New Zealand.
Are you selling mostly to the OEMs, or are you selling to are they making that part of the install, or are you selling to the final end customer, the utility or whoever?
I would say half and half. I mean, half of our business is done directly with the utilities, the end user, and about 50% is done through OEMs or integrators or EPC, even EPC contractors.
Okay, just because I I've been in the power industry for the last 15 years, and honestly, I had never heard of a bund before. I've heard of different containment systems, but maybe that's because I'm in North America and we were ignorant of the problem. But I know
I
there has
don't
been a
think so. I don't think
well,
so. Maybe you don't call it the same way. I assume you call it spill containment berms in the US.
that's exactly what we call it.
Yeah.
That's exactly what we call it, berms.
Okay.
And when I
Yes.
figured out what a bund was, I thought, oh, it's a very high quality, very unique. But talk about what makes the bunds that you provide different than what we normally use is just a berm, right?
Yeah. That's correct. I mean, traditionally, most of the end users use concrete berms.
Correct.
This is what has been done for the past 50 years. And we come here with a different solution that is a metallic, hot dip
Right.
galvanized steel bond with different advantages or disadvantages compared to the concrete bonds. So we just, thanks to the metallic bonds, we minimize the on-site work. We deliver the bond and we can install a very large bond, something like a berm, sorry, something like 70 square meters or even larger within 1 or 2 days max.
Really?
If you build it in concrete, it will take weeks and then 3 or 4 weeks to have it dried.
Yeah.
So it's quite a lot of time that can be saved thanks to the metallic bond.
There is another point about that contractors, the number of contractors that you bring onto a site, right, takes the amount of time, the amount of planning and everything. Concrete, and I have seen this too many times, concrete that is not allowed to cure creates all kinds of problems when you put the weight of a transformer, an oil-filled transformer on top of concrete. If the ground hasn't been prepared, if the concrete hasn't been allowed to dry and cure, guess what happens? You put the weight on it, the concrete cracks. Now you got to get the crane back in to lift the transformer back up and fix it. I've seen it, and it has been a mess out there. So now that I know that there's a solution, I encourage people to come up with a very solid and rapid solution. But well done. And so I
it's a
interrupted you.
rapid solution on site. I mean, to have it made quicker on site. So I mean, the quickest you go on site, the less risk of accident, of personal injuries you have. For heavy industries, for instance, don't talk about utilities, but heavy industry, they really don't like to run their oil refineries or cement industry on a safety transformer. I mean, suppose they have to do important site work on the main transformer, they really don't like to cut it for a month or two. There is a very high risk of profit loss.
You have a filtering system that you're introducing, correct? Tell me a little bit about that.
A filtration system. Well, you have those berms installed underneath the transformers. They can be metallic or built in concrete, whatever. Whenever the transformers is installed outdoor, the rainwater may drain traces of oil present on the transformer itself, right, and drain it into the berm. So that the water level in the berm, if you don't do anything, might increase and increase and increase. So you need to purify, to clarify, to treat the water and to evacuate the water, to continuously evacuate the water from your berm. If you use a safety siphon, your berm will remain full of water.
Right.
That's something maintenance operators don't really like. When you work on a transformer, on a powered transformer with cubic meters of water underneath, it's not really safe. And anyway, the standard, the electrical standard across Europe, but also US, request you to have the berm as empty as possible in order to have space in case of there is a huge oil, sudden oil leak and massive oil leak. You need to recover 100% of the oil inside the berm. So it has to be as much as possible empty of water. This is the reason why we have developed a few years back a filtration system based on absorbing polymers. Polymers that really like oil but don't like water at all. It's a oleophile polymer. So molecules of hydrocarbons are trapped into the polymer, whereas water can flow through the polymer.
Johan, your chemical engineering background just came out when you start talking about polymers and you're talking about the
Sorry
chemistry.
about this.
No, that's fine. That's fine. That's pretty exciting. But so there's a problem with water. There's also the problem with contamination, right? I mean, all governments are getting very restrictive because any kind of leak, any kind of oil spill is a contaminant. It is not. The EPA in the United States and Canada have the similar kind of, and I'm sure Europe has incredibly tough standards that you have to go by. So the filtration system helps with that. Explain that a little bit.
Well, I mean, what you're talking about is called, in most of the countries, it's called the Clean Water Act.
Okay.
I mean, each time you release rainwater or processed water into the nature, you must make first sure that you're not going to pollute anything. So you need to make sure that the water does not contain hydrocarbons. It doesn't mean anything. Does not contain doesn't mean anything. So the standard is written as follow. In certain areas, the maximum hydrocarbon content in the released water has to be lower than 10 milligram per liter, 10 milligram of hydrocarbon per liter of water.
Okay.
And in other areas or specific countries, the hydrocarbon content has to be less than 5 milligram per liters. Okay, so this is the standard. Those 5 milligrams per liter is the standard we follow. So we have developed this filtration unit based on this standard. So the released water, we usually release the water directly into the substation gravels, or we have lots of projects with hydraulic plants, and we release the filtered water directly to the river. Okay, making sure that it contains less than 5 milligram of hydrocarbon per liter of water.
So we have a lot of power plants that were built on water, right, for cooling. And now that back in the day, that was a sign of prosperity. When you saw a plant, right, billowing smoke. Today, we're very concerned. Society is concerned about pollutants getting into the water. So it's when you talk about a 5 milligram per liter of release, I can't fathom what scale is that? Because if you tell some people, hey, there's any hydrocarbons floating into the river, they're going to get upset. But obviously, you've got the lower standard than what happens in North America. The 10. I don't know if Canada is a 5 milligram or a 10 milligram.
No, I think California is at 5 milligrams per liter.
Oh. California leads the way in prevention, and soon everybody will move that way.
But to answer your questions, 5 milligram per liter is maybe a tenth of a drop of oil into a liter of water.
Okay, all right, that's scale. That we can understand. Okay, good. When there's a word that came up when we were prepping for this, and I think I know what it is. It's hydrophobic. So what does hydrophobic mean?
Hydrophobic means that the product doesn't like water at all, does not react with water at all.
Okay.
So there's no reaction at all between the absorbing media and the water, the rainwater. Whereas there is adsorption phenomena if you if you put some oil in contact with the absorbing media will react and capture the oil.
Talk about the range of the hydration filtration system, the rainwater hydration filtration systems you've got.
Well, we have developed, we have different filters. We have a filter, the smallest one is a 5 liters per minute water flow rate. This fits with retention berms of about, let's say 10 square meters. I will let you make the calculation to have it in a...
Right. 100 square feet.
Yeah.
Okay.
And then we have a 15 liters. That's a brand new filter that we can now put on the market. It's a 15 liters per minute, working also by gravity. Then we have a 1,500 liters per minute. This is a big one.
Yeah.
And working by gravity as well. And we also have a pump system for maintenance activity. This is about 50 liters per minute, the water flow rate.
So those applications are not transformer related applications.
They are all for the time being, 100% of our business is in transformer business.
Okay.
Around transformers. So those filters have been especially designed to treat the rainwater around transformers, electrical transformers. Yeah.
Now you said at the present time, is there work? Is there research and development going on to expand that, because that system can be used anywhere?
Well, it can be used anywhere where you have a potential risk of water pollution by hydrocarbons. Those type of filters, if you know that you have a mixture, water and hydrocarbon to treat, to separate, it's better to use physical decantation to remove as much of oil as possible. And then you can filter the water stage, the water phase. So this type of technology can be useful for any type of areas where you have a potential risk of water contamination by hydrocarbons.
Yeah.
Such as parking water treatment area, gas station, maybe.
Anywhere you have oil storage.
Yeah, correct. Yeah.
And as much as we'd like to think we'd move away from oil very quickly, it's going to take quite a long time to do that.
It's going to take some time, yeah.
Talk to me about
the filter, the technology itself, it works. It has been developed for dielectric oil, transformer dielectric oil.
Okay.
That is usually mineral oil coming from from refining business. But we also have absorbing media that has been selected to treat diester or veg-based oil.
Right.
Diester oil, or even synthetic ester oil. But the main, most of our filters are placed under a transformer that is running with mineral oil. That's the cheapest one, basically. And the absorbing media we use for the mineral dielectric, it works fairly well for crude oil, diesel oil, gasoline, avgas, aviation gasoline, any type of petroleum product, actually.
No, excellent. So you've got a broad range of growth that you can come up with at the company.
Correct.
I want to go to your manufacturing processes because I know certifications are important to you, that you've made sure that how you make the products that save the environment and save a lot of financial risk is important. So talk about your certifications, both in France and the ones that we recognize globally.
Well, I mean, basically, what is most important for our activity, we do site in France and in certain countries in Europe, we perform on-site work. So safety is the very first I mean, the most important item for us is the safety, personal safety, and then material safety, but personal safety first. So we have a local certification called MASE, M-A-S-E, that is supposed to be the highest level of safety procedure in Europe.
The
We have
equivalent, by the
this.
way, the equivalent here is NFPA when you have the National Fire Protection Association. Is that correct? That's
No,
no.
it's not exactly correct. There is an ISO equivalent for the safety. I don't remember the number, but
Yeah,
whatever. It is just, processes to make sure that you don't take any risk, that you analyze risk before you work.
yeah,
Before you do anything on site, you need to think about the risk and try to eliminate the risk as much as possible before you start working, actually.
yeah.
Because nobody wants an accident in an
Right.
electrical substation. We don't want any accident, and our customers neither. So that's the very first, the most important item for us is personal safety. Then quality. We have been dealing with major utilities in Europe mainly. We have been dealing with the heavy industry, like the petroleum industry, the cement industry, the steel industry. So all those big guys, they request a high level of quality. So
Right.
we are also ISO 9001 certified for quality. The filters are produced according to ISO 9001 processes, for instance.
Good.
That means we sample, I mean, we produce always the same way. We sample one filter every 10 or 20 to make sure it does pass all the tests.
If so my final question for you is a vision for the future. You're the CEO. You must cast the vision and leadership for the future of the company. What's your vision for the future of GMT and Accolec?
Well, my vision for let me answer differently. I mean, to translate my vision for of the future, I mean, I would like to take the opportunity to talk about this new filter that we have recently put on the market. This 15 liters per minute filter. It is called Filtrelec F15. And why is it my vision of the future? We have developed this filter to be more environmental friendly. So, for instance, this filter, I mean, the housing of this filter has been totally redesigned. And at the end, it offers about 70% mass reduction compared to the main products available on the market. So
Wow.
thanks to this mass reduction, I mean, we end up with reduction of natural resources required to produce the product. We end up with reduction of fuel consumption to transport the product. And we end up with reduction of the weight of waste generated when the product is being saturated by oil.
Okay.
And this is part of my vision of the future. We all have a role to minimize the footprint of our activity on the environment. So by reducing the weight, we managed to minimize this footprint. How we did manage to reduce the weight? By changing, by moving to traditional PVC to for your culture, polyoxymethylene and ABS terpolymer injection molded parts. They are much, I mean, they are more environment friendly for sure, but those materials also offer increased mechanical robustness and high UV resistance. Okay, so for instance, this product fits very well with the solar power plant. I mean, the photovoltaic power stations have been or that are being installed everywhere in the world. You have very tough conditions over there, economic condition first to build and to participate. The economic conditions are tough. And then the external, I mean, the ambient conditions are very difficult. So you need to end up with a very cheap product and very, very robust product. So this is basically what this new product offers. So my vision is like this new product, I mean, minimize our footprint on the environment and try to use our brain better to end up with nicer products, more environment friendly products.
That's the vision. And when you do it as a manufacturer and you minimize your footprint and you create a product that minimizes the damage to the environment or whatever problems you have, you cause your customers to minimize their product. So it's kind of like a win-win, both sides.
Of course, and they also minimize their cost.
Oh, that's kind of a nice advantage because most of the time, Johan, when I'm talking to people, what I find is you have to sacrifice at a little bit higher cost in order to minimize some of the damage we do. Like in making steel, to decarbonize a steel plant is very difficult to do, and there's some people in Europe leading the way. So
it
anyway,
is, but it's even better if you can end up with a product that is cheaper and more environment friendly.
Okay, quality products.
This is what we're trying to do, actually.
Yeah, but we call quality products that are less expensive, not cheaper, but better. Quality products, so I just recast your vision for you. But product development then has to be one of the benchmarks of what you're doing there. That you gotta keep making what you're making, but at the same time you have to do the product development in order to come up with these. I will ask you just how did you do that? How did you think about it? Did you challenge your engineers and say, here's what I want? Or did one of your engineers show up for coffee one morning and say, guess what I discovered? I'm always interested in how.
I mean, at the beginning, we had PVC housing envelopes. And we have already equipped very large solar farms in Australia or Mexico or in other countries. And after a few years, when we get photos or when we go on site after 2 or 3 years, and when you see your product being seriously damaged by UVs, the product is I mean, there's no color anymore. It's no big deal. But sometimes it can even break the plastic. I mean, if you expose your product to UVs, in Australia, for instance, after 1 or 2 years, the weight of the product itself breaks the plastic connections.
Okay.
The PVC, and this was this was a starting point of this new development. We understood that PVC is not the solution. I mean, if you want to have a product that stays outside, that is exposed to UVs, you cannot use such PVC, even though it's pressure PVC or reinforced PVC. You just delay the problem, but the problem does remain here. So we decided to think about, to study other plastic envelopes that can handle UVs much better. And at the same time, we did challenge ourselves to try to minimize the weight, to minimize and to maximize the environment-friendly aspect of the product as well. But initially, UV problem, and then the solution with
That's the vision. Environmental problems, manufacturing problems, solve them, and that's what a CEO does, right? That's your job. Well, well done. Well done. This has been an APC Media conversation with Johan Fornell. He is the CEO, as we've said, of GMT International and Acalec. They serve different parts of the globe. But thank you so much for joining us. The product and the process is fascinating. So I hope our video watchers and our interview readers will grasp this and will support what you're trying to do at GMT International. Thank you very much.
Thank you very much, Alan. Thank you very much for this opportunity.